Hi, welcome to this lesson on calculus, the factor and remainder theorems. Let's have a look at using the factor theorem, question 1. So we want to factorize the cubic expression 2x cubed minus 2x squared, 10x squared minus 2x plus 10. Okay, so first things first, what I can see is that 2 looks like it's a common factor to all of them. So I'm going to first of all take out a common factor of 2, and I'll get x cubed minus 5x squared minus x plus 5. All right, so now I'm going to let that be my polynomial p of x. So I'm going to use the factor and remainder theorems and say, well, the factors of 5 are either plus minus 1 or plus minus 5. So I'm going to try p of 1 first. So that's 1 cubed minus 5 times 1 squared minus 1 plus 5, which is 1 minus 5 minus 1 plus 5, and that gives me 0. So because I found a factor when evaluated gives me 0, by the factor theorem, I know that x minus 1 is a factor. So I can write this as, don't forget the 2 outside, into x minus 1 times a quadratic factor, ax squared plus bx plus c. Okay, so I'm going to use logical inspection and check what this value could be, and I'll also do polynomial long division to double check as well. Okay, so with logical inspection, what I have is 2 times x minus 1 times ax squared plus bx plus c. This must give me back my 2 into x cubed minus 5x squared minus x plus 5. So ignoring the 2's now because they're the same on the left and the right, I'm just going to focus on these terms here, because that'll make up my cubic. Okay, well from this I can see that if I let a equals 1, that'll help, because then the x squared times the x will give me the x cubed. And my c term, well, if I let that be negative 5, then negative 5 times negative 1 will give me my positive 5. So I just need this plus bx term. Okay, so now if I compare just the x squared terms, so x times bx gives me bx squared, and negative 1 times x is going to give me negative x squared. So those are the only x squared terms when I expand that out. But that must be equal to the x squared term on the right-hand side, which is negative 5x squared. So I can add x squared to both sides if I want. So bx squared equals negative 5x squared plus 1x squared is negative 4x squared. So therefore, dividing both sides by x squared, I get b equals negative 4. Okay, so this becomes 2 times x minus 1 times x squared minus 4x minus 5. But that quadratic expression can be further factorized. We can break it up as x minus 5 times x plus 1. Okay, so there's the full factorization using logical inspection. Now, let's go ahead and try polynomial long division to confirm this. Well, x minus 1 is that factor, so that's the divisor here, and I'm dividing it into that cubic expression, which in this case was x cubed minus 5x squared minus x plus 5. So now, if I do x squared on the top here, I'll have x cubed minus x squared. So x cubed minus x cubed is 0x cubed, negative 5x squared minus x squared. So that's negative 5x squared plus x squared. So negative 4x squared, and then bring down your remaining terms, minus x plus 5. So again, I'll do negative 4x here, so that when I multiply it out, I get negative 4x squared plus 4x. So negative 4x squared minus negative 4x squared is 0x squared. Negative x minus 4x, so that's negative 5x. And then bring down the 5, because we haven't used it yet. 5 minus 0 is 5. Okay, and then lastly, if I do minus 5 here, then I'm going to have negative 5 times x is negative 5x, and negative 5 times negative 1 is positive 5. So negative 5x minus negative 5x is 0, and 5 minus 5 is 0. Okay, so the remainder here is 0. And that's exactly what we came to expect. The x squared minus 4x minus 5 is exactly that quadratic term that we used, or solved when we did logical inspection. All right, so whether you do logical inspection or polynomial long division, as long as you get to the correct quadratic expression, and then if that can be further factorized, we factorize it, and then we have our full factorization of the cubic expression. All right, I'll see you in the next one.